Hello everyone, and welcome to the Waveshare ESP32 Arduino Getting Started tutorial. In the last lesson, we learned how to connect the ESP32 to or create a Wi-Fi network. Today we'll take it a step further and set up the ESP32 as a simple web server. This way, we can access the ESP32 from a phone or computer browser on the same local network and control the ESP32 through a web page. For example, we can create a simple web page to display information or remotely control an LED on-off. To achieve this, we will use the WebServer.h library, which is built into the ESP32 core library. For learning the basics and implementing simple local network control, it is a suitable choice. In this lesson, we will learn its basic usage through 3 examples. First, build a basic static web page. Then, control an LED through the web page. Finally, we will see how to implement the same functionality in AP mode. Source code and documentation for all examples are available in the video description link. Let's get started. We start with the simplest example. Let the ESP32 connect to Wi-Fi, set up a web server to respond to browser requests, and display a Hello World web page. Let's look at the code. First, include the Wi-Fi.h and WebServer.h libraries. Wi-Fi.h handles network connection, and WebServer.h provides the functions needed to build a server. Here, we define the Wi-Fi SSID and password. Remember to replace them with your own. Then we create a WebServer object named Server that listens on port 80. Port 80 is the standard port for HTTP services. When you access an IP address in a browser, the browser defaults to port 80, so you don't need to type it manually. In the setup function, we connect to Wi-Fi, which is the same as the previous lesson. After a successful Wi-Fi connection comes the key part of server configuration, server.on. This line registers a root rule. When a client visits the server root path, the handle root function will be triggered to process the request. Then we call server.begin to actually start the server. In the loop function, there is only server panel client. It calls the server.send method to send a response to the client. Finally, look at the handle root function. When a client accesses the root path, this function is triggered. It has 3 parameters. The first is HTTP status code 200, indicating success. The second is the content type text HTML, telling the browser that this is an HTML page. The third is the actual page content, generated by the helper function generateHTML that returns an HTML string containing Hello World. Now upload the code to the ESP32. After the upload is complete, open the serial monitor and wait for the Wi-Fi to connect successfully and display the IP address. Then open a browser on a computer or phone on the same local network and enter that IP address. Now you can see Hello World on the web page. Now let's go a step further. Use a web page button to control an LED connected to the ESP32. First, we need to build an LED circuit. To build this circuit, you will need an ESP32 development board, a breadboard, an LED, a resistor around 330 ohms, and several jumper wires. Connect the circuit as shown. After building the circuit, let's look at the code. The code structure is similar to the previous example. We'll focus on the added and modified parts. First, we define the LED pin and set it as output in setup. Then we add 2 new root rules. When a client accesses the LED on path, it calls the handle LED on function. When it accesses LED off, it calls handle LED off. The logic of these 2 handler functions is straightforward. Taking handle LED on as an example, it first turns on the LED using digital write, then sends the updated HTML page back to the browser to refresh the page state. Ending handle LED off works the same way. To achieve dynamic page content, we modified the generateHTML function. It now takes a Boolean parameter LED state, which represents the current LED state. Inside the function, we use an if-else statement. When LED state is true, the web page displays LED status on and provides a link to LED off to turn off the LED. When LED state is false, the web page displays LED status off and provides a link to LED on to turn on the LED. Now upload the code and see the effect. Visit the ESP32's IP address. The page shows the LED status and control links. Notice that when you click Turn on the LED, the page refreshes and the LED on the board turns on. Click Turn off the LED and it turns off. We have successfully achieved remote control of hardware through a web page. The previous two examples require an external router so that both the ESP32 and the computer are on the same local network. But in an environment without an external Wi-Fi network, we can make the ESP32 create its own hotspot, allowing a phone to connect directly for control. Now look at the AP mode code. You will notice that the server logic for controlling the LED, including root registration and handler functions, is exactly the same as in the previous example. The only difference is in the network configuration part of the setup function. Instead of using Wi-Fi.begin to connect to another network, we call Wi-Fi.softAP, passing in the desired hotspot SSID and password to create the network. After starting the hotspot, the ESP32's default IP address is 192.168.4.1. This is designed to avoid IP conflicts with common home gateways. If you want to change it, you can call the Wi-Fi.softAPconfig function before starting the hotspot to customize the IP, as described in the previous lesson on setting a static IP. After uploading the code, search for Wi-Fi networks on your computer or phone. You will find a network named ESP32S3 test. Connect using the password set in the code. Once connected, open a browser and visit 192.168.4.1. There you see the familiar control page, and you can control the LED as before. Thus, even without an external network, you can control the ESP32 via a web page. Well, that's it for this lesson. Let's quickly recap. We learned how to set up a web server on the ESP32 using the WebServer library. First, we implemented a basic static web page displaying Hello World. Then, we implemented web-based control of an LED. Finally, we demonstrated how to run the web server in AP mode. Thanks for watching, and see you next time.